So hey, welcome back to another video. In the last video, we talked about the introduction to exponentials and we looked at what exactly are exponentials and how they're called out and what the definition is. In this video, we are going to have a deeper look into where exactly can you use exponentials and also how to work with them and how you can simplify them if you're given multiple equations in front of you. So just to recap, you just have to remember that if I was to write 3 to the power of 2, that means 3 times by 3. 2 to the power of 2, it means 2 times by 2. Just keep that in mind. And a to the power of b simply means a times a times a times boom 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 times by a, and that would be done b number of times, right? So we'll highlight that and we'll close that down right there. So let's say, and normally the way we use exponentials is actually to simplify long equations that you may have in front of you to simplify anything. So for example, if you have something that looks something like this, 3 times 3 times 3 times 2 times 2 times 2 times 2 times 1. And then this is a pretty long equation to write. But then what you can do is, since 1, 2, 3, 4, you have 4 threes that are being multiplied by themselves. So you can just rewrite the above as 3 to the power of 4 times by 1, 2, 3, 4, 2 to the power of 4 times by 1. And so you see, like already here, you can see that how this equation can be, this line can be written in a much more simplified and a much more cleaner way to work with. And then actually, as a matter of fact, you can even just put this equation into the calculator, and then instead of having to write 3 times 3 times 3 times 2 times 2 times 2 times 1, you can just say 3 to the power of 4 times by 2 to the power of 4 times by 1 into the calculator, and you will get the exact answer right away. But this one was a much simpler, cleaner way of writing it. Let's say if they had mixed up the numbers. So if you had 3 times by 2 times by 3 times by 4 times by 3 times by 2 times by 3 times by 5. But now you see, now it's not that easy to see the commons, right? But still, just remember that when you're multiplying with each other, the order does not necessarily matter. So 3 times 2 times 3 is actually the same as writing 3 times 3 times 3 times 3, and then we can just put a bracket just to highlight it, times by, how many 2's do we have? So we have 2 2's, 2 times by 2, and then again multiplied by 4, and then I'll put a bracket for now, and then a 5. Right? So the point being that the order doesn't necessarily matter, especially when you're multiplying. So now we have grouped all the 3's together, all the 2's together, the 4's and the 5's there. And now we can rewrite this as 3 to the power of 4 times by 2 to the power of 2 times by 4 times by 5. So you see, so this is essentially the same equation as, or the same line as this one. But so you see, exponentials are mostly used to simplify these lines that you may have in mathematics, in algebra, or in any other place. Now these are very simple examples. You could even have replaced, we could have replaced this by variables. Like you could have, instead of 3's, you could have x's, and instead of 2's, you could have y's, and then you could also group them together the way you see fit. Uh, but the thing was that in these two examples, we were looking at multiplication. And within multiplication, yes, the order does not matter. So we could have we could rewrite this in terms of this. But let's take a look at something more, slightly more, I wouldn't say complicated, but something different. So let's say we had 3 times by 3 plus 3 times by 3 times by 3 plus 2 times by 3. Oops. Well, there we go. So we are back there. 2 times by 2 plus 2. Now, looking back at the definition, an exponential only applies to multiplication. And I'll actually rewrite it here. So a to the power of n is a times a times a, the n amount of times. But the main thing is that it's multiply with itself. Once we have an addition in the middle, then the order actually matters, because you can't move this 3 back there. That's not going to work. So the best way to do it is to actually group the multiplying numbers together. So this is one group, this is my second group, this is my third group, and this is my fourth group. So the only way you can rewrite this equation is by saying 3 to the power of 2 plus 3 to the power of 3 plus 2 to the power of 2 plus 2. So that is one term. Now a lot of people, they make this mistake that they just add these two numbers together by saying that, oh, since they're both 3 and they're both exponentials. But that's not how it works. You can't just merely add exponentials together by saying that, like, this is not equal to 3 to the power of 5. That would be very wrong. And you can't just add them together by saying 2 to the power of 3. That's not how it works. So just remember I think it's called the Damas rule. So you do the division first, multiplication second, addition, and then subtraction, right? So if you were to solve this equation, you would have to open up the exponentials first. So that would be 3 to the power of 9. Sorry, 3 to the power of 2 is, this would be 9, 27 plus 4 plus 2. So actually 27 plus 9, we can actually just solve it. Maybe 9 plus 27 plus 4 plus 6. 27 plus 9, that is what? 36. 36 plus 4 is 40. 40 plus 6 is 46. So that's what you end up getting. So, but of course, this is just a calculation. But the main idea was that once you have additions, in the previous example, you could see that we had the multiplication. Therefore, we were able to move the numbers around and group them together the way we wanted them to. In this case, you could not, because you had the plus sign in the middle. And once you have a plus sign, then that's a very good moment to look and consider about what it is that you're doing. Finally, you would have noticed that in all these examples, we were using 2s and 3s. And actually, just make a note here. You have to keep in mind that 4, that is of course 2, that can be rewritten as 2 to the power of 2, because 2 times 2 is 4. 9, that is 3 to the power of 2. 27, that is 3 to the power of 3. 25, that is 5 to the power of 2. So of course, there are of course thousands, infinite amount of numbers that you can get by multiplying two numbers together. But the point being that some of these numbers can also be rewritten in exponentials. Like if you ever see the number 4, it can be replaced with 2 to the power of 2, and the value will not change. If you see the number 9, it can be replaced by 3 to the power of 2, and the value will not change. So let's take an example here. Let's say that I was looking at a number of 3 times by 9 times by 27 times by uh, let's just say 5 times by 4 times by 25 times by, let's also take 8. And so that you're wondering, 8 is actually 2 to the power of 3, because 2 times 2 is 4, 4 2s are 8. Now, let's say that you don't have a calculator in your hand and you're asked to write this line as exponentials. Of course, like at first you probably look at it and you think that there are no same numbers being multiplied together, so you cannot rewrite this as an exponential. But if you look at it very closely, what you can do is you can rewrite many of these numbers as exponentials. So for example, 3 times by 9 can be rewritten as 3 to the power of 2 times by 3 to the power of 3, 27, times by 5 times by 4 can be rewritten as 2 to the power of 2, 25 can be rewritten as 5 to the power of 2, and 8 can then be rewritten as 2 to the power of 3. Now what we'll do, now since they're all being multiplied together, so just like the previous example, that means that we can move them around in the same line. So let's group all the 3's together. 3 to the power of 2 times by 3 to the power of 3 times by 5 times by 5 to the power of 2 times by 2 to the power of 2 times by 2 to the power of 3. There we go. So now since they're being multiplied together, now think of it this way. These three terms, let's write them out so you can visualize what it is that they mean. 3 times by 3 squared means 3 times 3. 3 cubed, or 3 to the power of 3, means 3 times by 3 times by 3. This is like the simplified or the expanded version of these three terms that we have right here. So you had the 3, that's there. 3 squared, that is 3 times 3, and then 3 cubed, that is 3 times 3 times 3 times 3 times 3. So that's kind of a tongue twister, isn't it? So 3 times, there you go. That means now if you look at it closely, we have all of them, they are 3's, and they're being multiplied by with each other how many times? 1, 2, 3, 4, 5, 6. So you can actually just rewrite this as 3 to the power of 6. And then let's write that as 3 to the power of 6. Using the same logic, that means that 5 is being multiplied by itself 2 times, and then we are multiplying the third 5 there. So that would be 5 to the power of 3. Finally, there are 2 2's being multiplied, and there are 3 2's being multiplied. In total, there are 5 2's that are being multiplied with each other. Then you can just rewrite this as 2 to the power of 5. And that is how then you essentially get an exponential from from a line that looks something like this. So you see, when you're looking at these long equations, or not equations, but like these lines, the thing to remember is that the first thing you need to look out for is that are there any numbers that are being multiplied by themselves? If they're all being multiplied by themselves, then you can always group them together. You can group them together, and then you can rewrite them as exponentials. This is kind of like the easiest example that you would see in exponentials. The second one being that you have a mix of terms being multiplied, and then you have an addition in the middle. Every time you have an addition, that means that there are different groups, and you cannot make exponentials across those groups. So in this case, you could see that we had a 3 here and we had 3's here, but they belong to two different areas, two different groups. So then you would have to write them as exponentials as independently. Finally, you would see examples where you would have different numbers, but different numbers can actually be rewritten in terms of exponentials. Like 9 can be rewritten as 3 squared, 27 can be rewritten as 3 cubed, and then by doing so, you can simplify a line that looks something like this into something that looks like this. And then this is much more easier to calculate, or much easier to visualize, especially once you get into the variables and algebra. So that essentially is how you actually use exponentials in mathematics and in different algebraic context, what the case may be. But yep, so well, thank you for watching, and do remember to watch the next video where we'll look more closely into rational exponentials. So thank you.